Problem 8 deals with a rock. And we're going to take this rock and eventually put it in the water. But if we would take this rock and weigh it outside of water, it weighs, 54 newtons. Now if we take this rock and we put this rock underwater, this same rock has a different weight. The question is, what is that weight? We only know that this rock has a weight of 54 newtons, but it also has a volume of 2.3 times 10 to the negative 3 cubic meters. Okay? Well, if we know the volume of the rock, we can figure out the buoyant force that acts on the rock. Buoyant force, FB, is equal to the density of the fluid, gravity, and the volume of the fluid displaced by the rock. Plug it in these numbers. This is in water, so it's 1,000 kilograms per cubic meter, 9.8 meters per second because we're here on Earth. The volume, which I'm going to write differently, I'm going to write 0.0023 cubic meters. When I multiply these numbers together, I get a buoyant force of 22.54 newtons. So the next question is, well, what happens? Well, let's look at our rock. If we draw a free body diagram of this, we know there's a force going down, the weight. We also now know there's a force going up, the buoyant force. The buoyant force is 22.54 newtons. The weight from earlier we know is 54. Well, how do we know what this apparent weight's going to be? Well, it's the difference between the two, because 54 newtons pushes down, but when it's in the water, there's another force that pushes up. So what we do is subtract these two, and we get a total of 31.46 newtons as the apparent weight.